The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to today's Pedestrian and Bicycle Information Center webinar. This is the second installment of our two-part webinar series that are focusing on pedestrian and bicycle count data. On Tuesday, if you were with us, we took a dive into the why and how of count programs, and today we'll actually be taking a closer look at counting equipment. So we're glad that you're able to be here to go through that with us. My name is Dan Jeline. I'm a program manager with the Pedestrian and Bicycle Information Center, and I'll be facilitating the webinar today. We are lucky to be joined by a great group of panelists who will be talking all about counting equipment. First, we'll be hearing from Krista Nordback. She was with us on Tuesday. She's a senior research associate here at the UNC Highway Safety Research Center. She's going to be giving a recap of the first part of our webinar series that we held a couple of days ago and set the stage for today's discussion about equipment. Frank Prue will come up next. He's a senior planner and researcher at Alta Planning and Design, where he works on a broad spectrum of bicycle and pedestrian projects. He's here to discuss automated counter technologies and share the latest findings on counter accuracy from round 2 of NCHRP 797. Sarah O'Brien is the Bicycle and Pedestrian Program Manager at the Institute for Transportation Research and Education, or ITRE, at North Carolina State University. She'll explain methods used to validate and maintain counter accuracy for the North Carolina Department of Transportation. We're thrilled to have all these panelists here with us today and very much looking forward to their presentations and the discussion. I'd like to just shift gears for a moment and talk through a few housekeeping items. Attendees, if you can hear me, please click the hand icon located in the upper right-hand corner of your screen. When you raise your hand, that'll let me know that you can hear us clearly and that we're coming through to our audience. I see hands going up. That's great. Thank you all very much for letting us know. We're glad you're here today to share some of this information with us. If for some reason during the webinar your computer freezes, I'd ask that you just please reload the website and log back into our program. You should be able to rejoin the session that way. We'll be posting, we already have posted presentation slides for this webinar on our website. I'll share a link to that in just a moment in the chat pod. We'll also be posting a recording of the webinar that'll be available within 1 to 2 days. So as you're going through the material, don't worry too much about taking detailed notes. You'll be able to look back at anything you might miss. Please note that attendees won't be able to speak during the webinar, though you will have the ability to submit questions to us and comments using the chat function located in your GoToWebinar control panel there. You can feel free to ask questions at any time. We'll be holding about 25 to 30 minutes of discussion period at the end of the webinar to handle those questions and get into more facilitated discussion with our panelists. Later today, you'll be receiving a follow-up email from the UNC Highway Safety Research Center with a link that will allow you to generate a certificate of attendance for this webinar. So if you're attending the webinar with multiple attendees at your given site, and you were the one who registered, please just make sure to forward that email around to those who are sitting with you so that they can also get their certificates of attendance. The email is going to contain a link to the site where we have posted the slides from today's webinar, and we will be posting the video within a couple of days. So you'll have that handy. We've also put a bunch of links to helpful resources there that we'll mention throughout the webinar. The webinar has also been submitted to the American Planning Association to be considered for 1.5 CM credits. If those apply to you, I'd encourage you to please check the online AICP event calendar to learn more about that. You can learn more about all of our PBIC webinars or watch some of our past episodes at pedbikeinfo.org/webinars. I'd also encourage you, if you want to keep up to date with PBIC, we're on Facebook, Twitter, we have a mailing list. We'd encourage you to go through all of those and sign up if you're not already. In particular for Twitter, we're going to be following along the webinar today using the hashtag PBIC webinar, so I'd encourage you to take a look at that. There are 2 upcoming webinars I wanted to make sure you knew about before we get into the main presentation today. First, the Association of Pedestrian and Bicycle Professionals is going to be hosting a session on June 21st called Beyond Counting, Putting Data to Work for Better Planning and Evaluation. So that's going to be a nice next step from this webinar series. They're actually going to be talking all about the data and what you can do with it. So I'd encourage you to visit apbp.org to get signed up for that one if you're not already. Our next webinar after today will be held on March 14th. We're running a session co-sponsored with the Governor's Highway Safety Association on laying the groundwork for successful safety education and enforcement activities. So if that's an area of interest of yours, we'd encourage you to visit pedbikeinfo.org/webinars to find the registration link for that. All right, we're almost ready to start our presentations. I just want to take a quick poll of the audience to find out about how many people are out there. We'd just be interested in hearing from you about how many folks are attending from your site. So if you could take a moment and cast your vote in this poll, that'll help us. That'll help us kind of figure out what our audience is looking like for today. We don't want to spend too much time on this, so if you can just quickly respond to that poll, maybe in the next 10 seconds, we will move right along with our presentations. Maybe just 3 more seconds for that poll before we close it up. We do appreciate all your feedback. Okay, thank you very much. I'm going to close the poll now, and we are going to move on to the first of our 3 presentations. Krista Nordback will begin by recapping Tuesday's webinar and setting the stage for our discussion today. So Krista, whenever you're ready.
Great, thanks so much, Dan. So as Dan said, I'm going to just try to recap what we learned from Tuesday. Why are we counting? What are the basics of a traffic monitoring program, especially a non-motorized program, and some resources you can use. So why are we measuring? Because if we don't count it, it doesn't count. In this world of performance measures, that's very important. So let's think about this example. Here is a suburban intersection with 6-lane highway intersecting a 2-lane arterial. And we have a pretty long crossing distance. How many people do you think on a nice or average day in September might be crossing here? How many crossings would you expect for this suburban intersection? And this happens to be in Oregon. So just get a number in your head. Okay. So the actual answer is 596. So when I've asked this to groups of people who aren't very familiar with biking and walking counts, they often say maybe 50. You know, that it doesn't look like the kind of place where you would see a lot of pedestrians. Although you may notice there is a little bus shelter there. So having a quantification of cycling and walking allows us to understand better what's going on this intersection. How do we design for the people who are walking here or bicycling here? How do we do our signal timing? How do we figure out bicyclist and pedestrian safety at these intersections? How do we evaluate how this is impacting public health? There are a lot of questions we need to answer, and if we don't have that fundamental information about how many users of each type there are, we can't answer that. So the evolution of cycling and walking counts. Manual counts have been going on for a long time. Back in 2004, the National Bike Ped Documentation Project came up with in coordination, ALTA in coordination with ITE, have a procedure for how to do that. It's online. Dan is sending out the link to that right now. So that was a standard methodology, and there are now also more equipment that Frank Prue is going to talk about that are available for counting cycling and walking. Up in the upper corner here, we have an inductive loop combined with an infrared counter so that when the warm body goes by, we can figure out if they happen to have 2 wheels or not and separate out the pedestrians from the bicycles. Similarly, for a temporary installation, one might consider using tubes to identify the 2 wheels and an infrared counter. So we have many more options now, and that's wonderful to improve the amount of time we can count. And in 2013, we had the traffic monitoring guide that was published with the chapter devoted to non-motorized traffic, and section 7.9 and 7.10 talking about how to format your data for inclusion in the travel monitoring analysis system that is kept by FHWA. That's where all the motorized traffic data live. And now, according to what we heard on Tuesday from Jeremy Raw at FHWA. This year is the first year that non-motorized count data, biking and walking counts, will be allowed in that data set. So very exciting. It was updated in 2016, so the latest, greatest format is what you should be using if you want to include your data in the national data format in data set. So make sure to go online to find that, and you should see that link in the chat pod. So we now can compute annual average daily pedestrian traffic and bicycle traffic. Scott Brady talked to us about different types of counting programs. So we have a permanent count program that counts 24 hours a day, 365 days a year, and that's how we can tell change over time. Then we also have cyclic counts and project counts. So a project count might be, I want to understand travel on this particular facility before and after a facility was improved. Cyclical counts would be where you have a program where you count every year or every 2 years or every 3 years at a certain set of sites. And in Scott's example, he was counting, I believe, 150 locations and cycling through those different sets each year, but then cycling around every 3 years. Each site would be counted. So the reason we need to do both permanent and short duration counts is that we can't afford to put permanent counters everywhere. They're just too expensive, both to purchase and to maintain. So the cyclic counts, or the project counts, they fill in where we can't afford to put the permanent counters, so we can understand better what's going on across the network. And if you just had a cyclic count or a short duration count, you couldn't understand what was going on throughout the year. So it's very important to have the permanent counter also, so you can estimate the annual average daily bicyclist. If you don't do that, you can never get to annual average. This is an example of the trail counters that Scott showed us for the Delaware Valley Regional Planning Commission. And there are over 10 counters here on their permanent sites. And at those sites, we know the annual average daily bicycle and pedestrian traffic because we can just sum up the data for the whole year and divide by 365. At these locations, the cyclic counts, which you can see are all across the network, and that doesn't include the project counts, just the cyclic in this one, and we can see he's using tube counters for that. We know just a count for a whole week. They count for 7 days. Well, how do I get to annual average daily pedestrian and bicycle traffic if I only know 7 days? Well, I know what's going on at the permanent count station, and Scott explained how he creates seasonal adjustment factors for each day of the year to adjust that seasonal count, because he knows that on days when there were bad weather events, that count may be lower than average, and he can factor that number up. But for days that are very good weather, he may see it much higher than average count, and he can then factor that number down based on the weather and the other events going on just from the data he gets from his permanent counters. And then he can get the estimate of annual average daily bicycle and pedestrian traffic at each of those sites that he only has the 7-day count for. Handy. Then Jeremy Raw at Federal Highway discussed the pedestrian bicycle technology pilot, and you can go to the link there to find out more about that project, working with agencies across the U.S. Then he also talked about the Travel Monitoring Analysis System, TMAS, which, as I mentioned, will accept data in 2017. And we did a quick poll and found out that 38% want to both use and contribute data to TMAS. So that was very encouraging to see that 38% of the listeners on Tuesday's webinar were interested in that. So for them, it's very important that they go to this guide for the TMG non-motorized format that Kelly Loftuson talked about, and that again is available online. This guide allows the users to understand how to code the traffic monitoring guide format so that their data can be added to the TMAS database. So in conclusion, We use permanent counters and short duration counters, and we need both of them. A program is incomplete if it has just one or just the other, because we cannot understand the change over time if we do not have a permanent count station, and we cannot understand what's going on all across our network if we don't have short duration counters. Short duration counts ideally would be 7 days at least, so we would include weekends and know if we had high weekends or low weekends, as well as knowing when the peak is during the day. Counts on high volume months tend to lead to more accurate estimates of annual average daily bicycle and pedestrian traffic. And validating your equipment is very important to make sure it's working correctly. And Sarah O'Brien today is going to give us great information on that. And sharing data is also very important, as Jeremy and Kelly talked about, so that we can make the most of the data we have. And with that, I will give it back to Dan. I'm looking forward to hearing what the next presenters have to tell us.
Great. Well, let's not waste any time then and get right into it. Frank, the screen is going to come your way, and let me know if you get that alert, and go ahead and go full screen, and we can get into the presentation.
That's good. Thanks, Dan. Do you have my slide showing?
I do. Go right ahead.
Awesome. All right, thanks. So thanks to Dan and Krista for having me here. I'm going to be speaking today about specific technologies that can be used for counting, biking, and walking. My primary goals with this segment of the presentation are to give all of you an overview of what technologies are available for conducting bike and pedestrian counts, and to give some guidance on how to pick the right tool for the job, depending on what type of count you happen to be doing. The primary source material for this presentation is National Cooperative Highways Research Program Report 797. This was a project that Kittleson and Associates led, and I worked on in my previous affiliation at UC Berkeley Safe Track. And then on top of that, a follow-up to that project, NCHRP 719 Part 2, which is just now, as of this week, going into publication as NCHRP web-only document 229. So keep your eyes peeled for that. It should be coming out imminently. Other good sources for this include the recent Exploring Pedestrian Counting Procedures document that the Federal Highway Administration recently put out and that Krista worked on. And of course, the Traffic Monitoring Guide includes information about technologies as well. So the first thing in thinking about count technologies is to think about what type of counter you want to be using for a particular application. And with this, there are three main questions to answer. First is, how long do you want to count? Do you want this to be a continuous counter, which I'm marking with a little 365 for 365 days of the year, or a short duration counter for your cyclical or project counts? Second, you need to think about who you want to count. Do you want to count pedestrians or bicyclists separately, the two of them at once separately, or just a lump sum count of total non-motorized activity? And then finally, the question to ask is, where are you going to be doing your counts? Different technologies are more or less suited to particular installation locations. Some are well suited to installation in bike lanes. Others might work particularly well on multi-use paths and sidewalks, which I'm denoting with the general heading path. And others work well for mixed traffic, meaning mixed bicycle and vehicle traffic. So for each technology that I speak to, I will be showing these graphics to give some idea as to the particular cases that it is well suited to. I'll also be speaking some to counter accuracy, and this is one of the big outcomes of the NCHRP 719 project, as we did extensive field testing of various count technologies. There are generally, I'd say, two primary approaches to evaluating the accuracy of a counter. The first is what I would call the disaggregate approach, where you look at every event that occurs, either somebody passing your sensor and your sensor recording a count, and evaluate how well it's doing in terms of accurate detections, as well as both false positives and false negatives. This approach is nice in that you can diagnose particular issues that are occurring with your counter, but it is much more labor intensive than the second approach, which is the aggregate approach. This approach is where you watch your counter for some specified amount of time, maybe 15 minutes or an hour, and conduct a count of what you think your counter should be collecting. Then at the end of that time period, you compare your count against what the sensor recorded. This is the approach that was used in NCHRP 797, and is what I will be depicting the results from here with scatter plots like the one shown on your screen. These scatter plots show on the vertical axis the automated count observed for a particular hour, and on the horizontal axis the manual count conducted based on video footage for that same hour. So ideally what we're looking for here is things to fall on that 45-degree line where the manual count is equal to the automated count, meaning for that hour the automated counter was accurate on average. This is one disadvantage to this particular approach, is that you can have false positives and false negatives cancel out. But at the end of the day, if what you're interested in is getting an accurate overall count, then this can be a useful way to validate your equipment, although it might not give you the fine-grained information that you need to diagnose particular problems that are occurring. On these plots, any point falling under that 45-degree line corresponds to an undercount, and above that line corresponds to an overcount. Undercounts can occur for a variety of reasons, but one of the primary ones is what's known as occlusion, which is where two people or two bicyclists or two vehicles pass the sensor simultaneously and the second object is not recorded. So now I will start getting into some of these technologies that are available. The first, of course, is the simple manual count conducted in the field. This is where you would go out with either volunteers or your staff and conduct counts on a clipboard or some sort of count board or a smartphone application. This is one primary advantage of this approach, is that you can collect other information that might not be available from an automated counter, such as demographic data, including gender splits or helmet usage, and also that you can collect turning movement counts, which is typically a difficult thing to collect with automated count equipment. This is generally a very flexible approach, but is very costly to collect for a long amount of time, so it's really only suited for those short duration count periods. The next approach, which is very closely related, is collecting manual counts based on video footage. So this is where you go out and install a video camera at your data collection site, then take that footage back to your office and watch it at your leisure. This can presumably give higher accuracy because you can review footage if you need to, and also can be more time effective as during low volume periods you can review the footage at faster than real time. For these reasons, it's presumed to have high accuracy and is also very flexible, similar to the manual counts in the field, but again has that high cost problem, and therefore is only a short duration technique. We've also got in the field automated video technology. So this is where you have your video camera installed and a computer vision algorithm is run on it to identify objects and classify them as pedestrians, bicyclists, vehicles, or other, and to collect a summary count based on those classifications. There are a couple of technology out there on the market that can do this currently. Most of them are more suited at this stage to short duration applications because they're priced on a per hour basis and therefore might not be suitable for continuous monitoring. And there's been limited third-party validation, although some preliminary sources suggest that they work fairly well. Now I'll start getting into technologies that we have actually tested in CHRP 797 and showing some of the results of those evaluations. One of those is thermal imaging. This is a technology that is similar to the automated video technique, except that rather than looking at the visible spectrum, it considers the infrared spectrum. So this isolates things like body heat and might have higher accuracy in situations where there are lighting problems or other visibility issues that could potentially affect a video camera. In round 2 of the NCHRP project, we tested one such device for the particular case of counting bicycles in a buffered bike lane, or actually cycle track segment, and found that it worked well for this application for volumes up to approximately 300 per hour, as shown by the plot in the lower right corner of the screen. One consideration with this, however, is that it does require hardwiring into the electric grid, and so typically will require a signal mast arm for installation. Next is passive infrared. So these are a very commonly used technology for monitoring, particularly on multi-use path situations or on sidewalks for conducting pedestrian counts. Passive infrared sensors detect, similar to that infrared video, based on body heat and thermal profile of people passing by, and based on this can identify individual people. There are products out there that implement this technology for both short duration and continuous monitoring applications. But this technology is limited in that it only gives you a lump sum count of bicyclists and pedestrians, or more generally, overall warm bodies passing by your sensor. We've tested 3 of these in the NCHRP project, 2 in the original phase, and then a 3rd product was added in the follow-up study. And you can see the results for each of those 3 technologies in the bottom right corner of the screen. As we can see, there are slight differences in how they perform, but overall, again, they all work fairly well, just with the caveat of that you only get a lump sum count. Next is active infrared. Active infrared is probably what you think of when I say infrared. This is where you have a laser beam between a transmitter and a receiver. And when that infrared beam is broken, a count is recorded. Similar to the passive infrared, this obviously only gives you a lump sum count because it's simply recording breakages of that beam, and is primarily suited to path type situations. We tested one device of this type in the NCHRP project, and only at one site, so these results carry that caveat with them that this is just based on one location. But with that in mind, this device also works very well. Pressure pads are a sensor that is installed under or on the surface of the ground and detects pedestrian counts based on the pad being stepped upon. These are primarily suited towards natural path type applications, as suggested by this photo shown here, but they're flexible in that you can install multiple pads next to each other and effectively build as wide of a sensor as you need for your particular application. There's been limited third-party testing of these devices, but it seems that they would also work pretty well, particularly if you don't have a case where pedestrians are lingering. That's something that can affect the accuracy of most count technologies, so something to keep in mind when you're doing your installations. Next, I'll speak to radar. So radar is where you have a transmitter and a receiver, where the transmitter is emitting radio frequency pulses, and based on the reflection of these pulses, classifies objects and conducts counts. There's a few different implementations of this type of technology, some that are installed under the surface of the ground and have a transmitter and receiver within the same unit. Others have a transmitter that's installed on one side of a facility and a receiver on the other side, and counts are recorded based on that connection being broken. Some of those can differentiate bicyclists from pedestrians. Others cannot. And depending on the type of product you're using here, it might be suited to short duration or permanent applications. We tested two different technologies that fit within this broad heading of radar. One of those was one of these radar devices that's installed under the surface of the road, and we tested it in a bike lane application. And it worked decently well, although we observed overcounting, which seems to be attributable to cars encroaching in the bike lane, which suggests that it might have difficulties when you have a heavy parking rate next to your bike facility, which was the case in our test location. So this is kind of a preliminary result in that there was only one application, and site characteristics might affect your performance. We also tested a single-sided lump sum radar counter and tested that at a couple of sites and found that those hourly counts were fairly close to the perfect accuracy line. Inductive loops are where you have a loop of wire installed under the surface of the road or path with a current going through it, so that creates a magnetic field outside of the loops. And when a metal object passes through that zone, it disrupts the current within the loops, and based on the characteristics of that disruption, you can classify objects that are passing through the detection zone. These are frequently used for signal actuation, but there are also units that are particularly made for conducting counts and for the special purpose of counting bicycles as well. These work well for the counts for bicyclists that pass through the detection zone. That carries with it the caveat that if bicyclists don't pass through the detection zone, they obviously won't be counted. And so when you're doing your installation, you need to keep that in mind to mitigate those so-called bypass errors. Pneumatic tubes are probably the preeminent short duration count technology for bicycle counts, as well as motor vehicle counts, of course. This is where you have two rubber tubes that are affixed to the road or path surface using brackets and nails or mastic tape. And when a vehicle passes over the tubes, an air pulse is generated, and based on the characteristics of the succession of those pulses, vehicles can be classified. This, as I said, is primarily oriented at short duration count applications for bicycles only. But some devices can be used for conducting both your vehicle and bicycle counts, including a wide variety of location situations, either in bike lanes or cycle tracks or multi-use paths, as well as mixed traffic in either urban or rural areas. We tested 3 such technologies using bicycle-specific tubes. So these are slightly thinner-walled tubes, so they're more sensitive to bicycles for detection. And most of those worked well in a variety of application situations, including mixed traffic settings. But the particular classification algorithm that you use can affect the accuracy of your count that you observe. So make sure you validate that when doing your installations. Piezoelectric strips are a material. Piezoelectrics are a material that, when it's compressed, an electric signal is generated. So these are functionally somewhat similar to pneumatic tubes, except they're a permanent installation that's installed under the surface of the ground for counting bicycles. The classification is similar to how pneumatic tube classification occurs. In the NCHRP project, we tested 2 such products on a multi-use path setting and found that they both worked extremely well. This is in part an update to the results originally published in NCHRP 797, and the results that come out in the web-only document 229 update those original results with these finalized findings. Finally, I'll speak to some combinations of technologies that can be used. So as Krista insinuated, one technique that you might use, and there are products that do this all within a single comprehensive unit, is use some sort of technology that counts all pedestrians and bicyclists passing by, paired with a technology that just counts bicyclists to get a separate bike and pedestrian mode split. There are a number of different commercial products that do this, including some that use infrared detectors, passive infrared detectors, and inductive loops, and this is particularly well suited to multi-use path situations. We tested some of these on multi-use paths, and shown here are the accuracy results for the pedestrian estimates separately. Both the inductive loops and passive infrared results underlying this were also included in those earlier results that I showed. Similarly, infrared can be paired with piezoelectric strips for a similar application of identifying separate pedestrian traffic volumes on a continuous monitoring basis. Finally, short-duration infrared devices can be paired with pneumatic tubes to create a mobile setup for the same application. We didn't conduct any accuracy evaluation of doing so, but this is something that when you're conducting your counts can fairly easily be done so long as you have a suitable location for installing both of those devices. So that's my overview of count technologies that are available. I'll conclude by suggesting that you all look at the traffic monitoring guide, page 4-4 for the selection matrix that has some similar information to what I've presented here to help guide your selection of technologies for a given situation. I'll say that there are a few remaining technological challenges with conducting bicycle and pedestrian counts that I think we're still waiting to see commercial products solve, but I'm hopeful that they will be solved sometime soon. One of those is continuous monitoring for pedestrian crossing counts. Similarly, continuous monitoring of bicycle turning movement counts. And finally, just the ongoing challenge of those bypass errors that I highlighted for on-street bicycle counts, where your sensor's detection zone doesn't subtend the entire width of the facility where bicyclists are traveling. And remember, always follow the installation instructions that come with your count device if you want it to work properly. This is the best way to get accurate counts. Calibrate your devices to make sure that those counts you're getting are accurate, and perform follow-up validation counts, which is what Sarah will be now talking about. Thanks for your time.
Great, thank you very much, Frank. Before we get the screen away from you, Frank, we did have a question. I think it'd be easier to answer it while we still have your slides. We had a question about your counts, your over and under counting graphic that you had shown on this. I think you had a big one up front. And a question about when, for the data you're presenting there, what does each dot represent in terms of time? We're trying to get a sense.
Each dot on these plots is, each dot on these plots is 1 hour of observation.
1 hour, okay. And the person made the point that that's for a manual data count. That seems like a long time. So I don't know. Is that an accurate statement, or is that?
Can you say that again? That seems like a long time to do a manual count. Is the concern?
Yeah, that was the question.
Yeah, I mean that is some time to do a validation count. If the concern is over accuracy in particular, we did these using video footage so that the data collectors could stop their work and take a break whenever needed to improve accuracy. And we also did some inter-rater reliability checks between our data collectors to ensure that they were doing good validation work.
Great, great. Okay, thanks for clarifying that. I'm actually going to launch a poll question right now that sort of gets at maybe asking you all about the technologies that you have experience with. And we didn't have ability to put all the options here, but we wanted to see if you could check as many of these as you can, just to give us some information, I guess, about what your most, which of these technologies do you have experience with using, whether manual, either in-field or from video, infrared, and we spelled infrared wrong, that's okay, passive or active, pneumatic tubes, inductive loops, or piezoelectric strips, or other. So we're just kind of curious. You can check as many of these as you have experience with, and after maybe a few more seconds, we can get those votes in, and I'll flip it around and actually show you all what everyone said. Just about 5 more seconds probably on the poll, so we can go ahead and move on to Sarah's presentation. Choose your options. Okay, all right, I'm going to close it, and let's see what everybody said. So, Frank, you can probably see the results there too, hopefully. So manual, in-field, or from video seems to be the tool of choice for most people, followed by pneumatic tubes, and infrared and inductive loops not too far behind, and some others, definitely some others that we couldn't fit into the options for this particular question. We were limited to 5, so that's helpful for us to know, and maybe helpful for you all to see what others are working on. So thank you all for that information. We're going to go ahead and move right along to the next presentation from Sarah O'Brien. So Sarah, you should see the alert come across your screen, and take that over and go ahead with your presentation.
Yep. Can you see it?
I see it.
Okay. So yeah, I'm going to talk about validation, but before I jump into that, I just wanted to give everybody a really quick overview of what we're doing. So I'm with ITRI, the Institute for Transportation Research and Education, and we're working with NCDOT to essentially establish their non-motorized volume data program. And basically it comes down to what Krista mentioned at the beginning: if you're not counted, you don't count. And NCDOT has been moving, as a lot of agencies have been, to everything being very performance-driven and having objective measures for their decision-making processes. So we've been working for a few years now to start up this program. And one of the pieces that we've been working on, when Krista mentioned that 3-legged stool, is we focused first on establishing the continuous count side of the program. And really that comes down to the fact that short duration counts are somewhat meaningless if what you're trying to get as your metric is annual average daily pedestrian or bicycle traffic, if you don't have continuous counters to develop those adjustment factors to be able to extrapolate your short duration counts. So we've started with the continuous count arm of the program, and really that means putting in permanent count stations. And one thing that's really important about the fact that these are kind of the backbone or the spine of the program is that the accuracy of the data that gets collected by these machines is really critical for the credibility of the whole program, and ultimately the usefulness of the data, not only from the continuous counters but also ultimately from the short duration count sites as well. So just to give you a broad brushstroke of the program as a whole, there are lots of different elements that go into this program and making it run successfully. And today, really all I'm going to be talking about is our QA/QC to some extent, and really focusing on how we validate the data that's being collected by these continuous count stations. But as you can see, there's a lot of different elements that go into having a program, and that's one thing I would say for anybody who's listening that's interested in starting their own program or interested in getting counts and has never done it before. It's really a lot more, or you should be thinking a lot more than just you know, what equipment or technology should I use, and throwing them out someplace to collect counts. There's a lot more thought that needs to go into it to ultimately be able to use those data as effectively as possible. So we do have a flowchart poster that's on our website, and I think Dan's going to be giving the link to that website towards the end. This is just a piece of that flowchart that talks specifically about what happens when we get the continuous count station data. And the reason I'm showing both some of the data handling processes as well as the equipment validation is that there's a feedback loop that goes on here. So for equipment validation, this is really kind of what we do when we're initially installing a counter to make sure that it's working correctly, and it's the information that we use to ultimately develop correction factors that then get applied at the very end to our raw data before we publish any reports, publish any data. We also have a validation process that happens with checking the raw data and checking it for 4 specific aspects. A gap check is essentially looking at whether there's a transmission error, whether data is actually coming in. If we have blanks, then that means that there's probably something wrong with our counter and it's gone offline. We have the consecutive zero check, which looks at a certain number of days that we are accepting for zero counts, and if it's too many days, you know, then that means that there's probably something wrong with our counter if it's not counting anybody over a certain number of days, and we have a threshold for that. We also look at the directional distribution of the counts to see whether that seems consistent and makes sense, and then we also have what's called the range check, which basically says over a certain amount of time what's typically our normal maxes and mins for counts at that site, and if a count comes in that seems unusually high or unusually low, it can get flagged for that as well. So those are the 2 pieces kind of as an overview, and I'm going to go a little bit more into detail with each. So for the validation study itself, to develop these correction factors, basically what we're doing is kind of what Frank talked about that they did for their NCHRP 797 study, which is comparing the manual counts to the automated counts to get that error rate and to be able to understand the accuracy of the automated counts. So our graphs are flipped from what Frank showed, where we have automated counts on the bottom and manual counts on the side, but it's still each data point represents that hour's worth of counts. So this is just for 2 different sites, or I'm sorry, for the same station, the same location. We've got pedestrian counts and we have bike counts, and so we have to validate both types of modes because the equipment may function slightly differently. Each sensor may function slightly differently for what it's doing. And I will say that the equipment that we're using, the technology we're using is infrared for the pedestrians and inductive loops to count the bicyclists. So what we're looking at when we're looking at accuracy is 3 different metrics. We look at the average percent deviation, which basically tells us how far overall the divergence is between the manual counts and the automated counts, or the counts from the machine, and that's kind of our baseline ground truth, if you will. But as Frank mentioned, a machine may overcount in some instances and could undercount in other instances, and so those could cancel each other out. And so we also look at the average of the absolute percent difference, and that gives us kind of a general consistency in the error. Is it typically overcounting? Is it typically undercounting? And then Pearson's correlation coefficient is a statistic that really represents linear correlation. So this is important in order to develop a model for the correction factor, to come up with the correction factor. You know, if it's not a linear type of equation, then you may need to have a higher order model developed in order to come up with your correction factor. For ours, we did some testing on this, and for all of our stations, there wasn't that much difference in playing around with different models and the fit of those models. And so ultimately, for each of our stations, we have a specific error rate or correction factor, which is essentially the manual counts divided by the automated counts. And in general, that means that if a rate is greater than 1, then that machine is undercounting relatively consistently, and if it's less than 1, then that means that that machine is overcounting relatively consistently. And I will say that we developed these correction factors for each individual machine or count location, as well as for the bicycle counts and the pedestrian counts at that location. So when should you do validation? Ideally, best practice says that you should annually validate your data. You should always be checking to make sure that your equipment is functioning properly. And the other thing I'll say is that when we're thinking about validation, we're really focused specifically on the equipment. We're trying to figure out if the equipment is malfunctioning or if it's functioning the way it's designed to function. And so in that case, Frank mentioned bypass errors. What we try to do when we're looking at the video to validate is we do document if there are any bypass errors, but we don't have that count against the equipment itself. If somebody goes outside or around the detection zone of that particular equipment, it's not the equipment's fault, and so the equipment is still functioning the way it's supposed to function, and the counts that equipment counts can still be tested for validity, but we note if there's bypass errors, and we do look at that somewhat separately as a way to let us know, maybe we didn't install this in the right location, or maybe we didn't install this in the best way to get the data that we're really interested in getting. So with every installation, we do a validation study that's basically tied to the install. We do some testing of the equipment as it's being installed before we walk away to make sure that it's functioning properly, but we also install the bullet video cameras and collect video data that we then post-process to actually to develop the correction factors. The other time that we'll do validation study is when a maintenance issue triggers it. So in this case, this is what the infrared sensor looks like when it's inside a wooden post. And you can see right here this hole at the bottom part of the sensor. Basically, there was some vandalism that occurred. Somebody probably pushed a pin or something in there and damaged a sensor. We were able to identify that through visually inspecting the data that comes in. We saw that there was a weird skew in the pedestrian counts, and that led us to go troubleshoot in the field, identify the vandalism, and now that means that we will replace the sensor. And so maintenance can trigger the need to do a validation study. One of the reasons we don't do it annually for North Carolina's program is that for now, ITRI is essentially acting as North Carolina's, as the DOT's agent for handling all the maintenance of the machines that are installed. And it's cost prohibitive for us to travel to all the sites to set up cameras and then post-process the video data annually. Plus, with just general maintenance that happens at these stations, we typically wind up needing to revalidate, and so we feel like we're able to capture and maintain the accuracy of the data just through the initial validation study and then any revalidation that has to happen through maintenance. So how do we do it? So here's what it looks like. We set up a camera, somewhat similar to what Frank showed a picture of. Our cameras are a little bit smaller. They're these bullet cameras, but we attach them to something that's relatively high. It could be an existing pole or tree, or we do have poles that we can bring with us if there's no great place to fasten it. But we put a camera up, positioning it towards the station, and then what these two different screenshots are showing of the video is that when we install the video camera, our person will go out and basically show via the footage where the screen line count should be, where they're counting on the facility. So in this bottom middle picture, you can see my coworker Shannon standing here. She's pointing towards the bollard that has the infrared sensor in it, and this is where the pedestrians would cross. And as long as they're crossing basically between her and the post, any pedestrian that's going, or really any user because of it being infrared, any person that walks or rides their bike or whatever across this this location, the screen line, will be counted by the equipment or should be counted by the equipment. So when our students are processing the data, processing the video, they're going to be manually counting anybody that goes across that location. In this top larger image, you can see both that same bollard with kind of an overlay of where the manual counts should occur, as well as where the bicycle loops are installed, the inductive loops. And one reason that we do this as we set up is because we actually set our video, our cameras to be at relatively low resolution so that they don't eat up a lot of server space, that the file sizes aren't really huge, because we do save all of the video data even after it's been processed, in case we need to go back and refer to it for any reason. And so it's sometimes difficult, especially if it's in a dark condition, for the student to necessarily be able to see exactly where the loops are. So when we install the camera, the person who's installing the camera then immediately walks out and basically shows where the edge of the loops are, so that the person who's processing it can set up something on their screen to mark where the boundaries for the detection zone should be, and then they can count the bicyclists that are going through that location. This in particular happens to be in a bike lane in Charlotte, North Carolina. And the van is there because they just finished installing the equipment, so obviously everybody's getting ready to leave, and then it'll be set up for validation. So we actually collect about 2 to 3 days worth of video. We usually install the camera and leave it out for, maybe 4 to 5 days. We have the system set up now so that we can leave information with the local agency, and they can package it. They can uninstall the camera, package everything back up to us really simply, and just ship it back to us. We give them a label. So now we don't have to go back out to actually collect the video equipment. But we also leave it out long enough so that if there's a weather event, or like right now our cameras don't collect overnight when it's dark conditions, so we leave it out to make sure that we get at least 24 to maybe even 30 hours of footage that we can actually process. So in the NCDOT P797 report, their rule of thumb is to have at least 30 time periods that you can process to compare with your automated counts. And they basically break that up into two different ways of looking at that. You can have 15-minute intervals for your counts that equate to about 8 hours worth of ground truthing, or if you bin everything in 60-minute intervals, then you need at least 30 hours of ground truth data. And you want to ultimately have data that's collected over a mix of volume ranges. So when we set up our cameras and we leave them out there, we come back and we post-process essentially all the daylight hours where we can see what's going on. And that means that typically, because the travel pattern is changing over the course of the day, we get a mix of low, medium, and high ranges, at least for that location. Doesn't necessarily mean that it's high in the sense of 300 bicyclists at every location, for example, but high for that particular site, because everything is site specific. So the automated machines that we use do bin everything in 15-minute intervals. So for our manual counts, we also bin everything initially at a 15-minute interval. So that's what this spreadsheet is showing for this particular station. We were looking at, we collected the video data on October 14th. It was a Wednesday. We've got the start time for when we started collecting that data, and this is just kind of a default for our spreadsheet to fill in, but the video actually, the processor, maybe it was too dark at 6 o'clock, who knows what, but they started processing at 7 o'clock in the morning, and then you can see what the eco counter count was versus our manual counts. That information all gets aggregated then to an hourly count, and then we look at the difference between the two, the ratio between the two. One other thing to note is that we also typically try to do this. You really need people to be counted. If you have a day of the week, or if you're like in the winter and nobody's out walking, and you have a lot of zeros for your manual counts, it's going to be really hard to know whether your machine is accurate or not. If it's zero, there's nothing to count. So you really need some data in order to be able to validate your data. The other type of validation that we're doing is with our QA/QC process, and I mentioned briefly the checks that we have, but basically we've got a spreadsheet with a lot of different formulas in there, and we run the raw data through, and it's somewhat automated, so it flags data that's suspicious or may be suspicious. Anything that's not flagged is automatically considered valid because it's within thresholds that we have established. Then the data technician has to go back into anything that's been flagged and make a determination about whether that data actually is valid, but maybe it's atypical for some reason, or whether that data is invalid and ultimately we need to scrub it from the data set. So some examples of that would be, if there's no data whatsoever, like a transmission error or something like that, that's automatically going to get scrubbed as being invalid. If there are unusually high or low count volumes that we can't find an explanation for, or if there's a high skew in the directional distribution that isn't explained, that data is going to be invalid, and we would scrub it from our process. Sometimes we're able to explain unusually high or low volumes. We can look at what we call the ramping up or ramping down of the volumes. So say a particular hour gets flagged or a day gets flagged. We'll go back and look at the full data for that day, maybe even the same day of the week, a week before, a week after. It's a little bit subjective, and it's a little bit of a, digging around to see what you can see. But we are able to identify patterns that make it look like it's probably a special event or race. Sometimes we'll go back and look, well, is this day of the week, was it a holiday? Is it, Memorial Day or Halloween in Franklin Street in Chapel Hill, or was there some extreme weather event that happened? And that may be enough to be able to explain the data and keep it as being valid but atypical. So here's some examples of what we look at. So this is a screenshot of the EcoVisio software that comes with the particular counters that North Carolina is using. And I know it's a little grainy up here, but basically for this one on the left side, what we're seeing is the yellowy green line is for pedestrian counts that are going eastbound, and the blue line is for pedestrian counts going westbound. The red line, which is very difficult to see because it's all the way here flatlined at 0, is for bicyclists that are going westbound. So basically this is a station where we've got one unit, one counter, that logs both pedestrian activity that's happening on the sidewalk as well as bicycling activity that's happening in the street. Unfortunately, what we're seeing here is that there are no counts for bicyclists, and so that may suggest that either there's a faulty sensor, that for some reason the bike logger stopped working, or maybe something's wrong with our loops. It basically suggests that there's something that we need to go back and check and see what the maintenance issue is to troubleshoot and correct. On the right side, what we're seeing is, again, pedestrian activity up here and then bicycling activity down here. But you can see that it stops. We've got data that goes from March 2016 through, beginning of March to Sunday, March 6th. And all of a sudden, the rest of the days, there's nothing. And so when there's no data, not just zeros, but no data, then that's probably some sort of transmission error. And if it happens long enough days in a row, then that means there's probably something wrong with the count equipment. And so that's something that has to be investigated. Here's another example at a location, and this is, here I'm showing a few months worth of data. You can see that there is some variation in the pedestrian counts across the months, but in general it doesn't get higher than, maybe 750 or so for the counts, for a daily count for pedestrians going northbound. And then all of a sudden, as we get towards the middle of October, we see this crazy spike in pedestrians going southbound, and northbound just crashes. And so then we look a little bit further, a few months further, and you can see, wow, there's some really crazy stuff happening here. Now, right now, we are still troubleshooting this site, so I can't tell you exactly what this pattern is showing, but my guess is that either the battery died, because as the battery starts to get low in its life cycle, it can start doing really weird things to the sensor or to the counts, or it may suggest that there may be water damage or corrosion to the system, or the sensor itself has totally failed. However, because we're seeing funky data in the pedestrians as well as the bicyclists, which is hard to see in this image because of the scale of the axes, but basically eventually the bicycle data winds up flatlining. That suggests to me that it's more than just a malfunctioning sensor, because there's two separate sensors that are pulling together to give us the bicyclist and the pedestrian data. So maintenance definitely can trigger the need to revalidate, but not necessarily in all cases. When we revalidate for a maintenance reason, it's because there's something that would be creating essentially a new normal for the data. So remember, we're using our validation study as a way to come up with a correction factor that's ultimately going to get applied to the scrubbed data in order to adjust for a consistently over counting machine or a consistently under counting machine. And so things that might trigger the need to revalidate would be changing a sensor for sure. If we, like that one that had the vandalism in the infrared, when we replaced that part, we've got a new infrared sensor in, so we definitely need to revalidate. However, if there's an obstruction to the sensor, like for example, we've had a spider egg sac that blocked the view of one of the infrared sensors, once you clear that obstruction, you don't necessarily need to revalidate because it's not changing the functionality of the equipment itself. So anything that's, if you're changing the settings or the functionality of the equipment, definitely you need to revalidate. If you're just changing out the battery for normal routine maintenance, that shouldn't be an issue. So here's an example. It's really, really hard to see, but there is a crack in the wire here, and I believe this wire was going from the logger to our bicycle sensor, if I remember correctly. That actually wound up exposing the entire system to water damage, and so that system had to be replaced. And so that is definitely something that's triggering the need to revalidate. Down here, this is in part of the equipment that sits in the ground. This black piece is just the transmitter to provide cell service. It's like an antenna. And it's really hard to see, but all those tiny little black flecks everywhere is basically an insect infestation that's just starting. They were building some, little eggs over here. They were kind of hanging out, hiding underneath this thing. We caught it before it actually damaged any of the equipment, but that's something that you do need to monitor for to make sure that you don't have any damage to the actual equipment. And in this case, at this point in time, we don't need to revalidate at this site because we didn't have to change out any of the parts. So that is all that I had to share, but I'm certainly welcome to answer questions.
Great, thank you very much, Sarah. We have a poll question just to follow up on your presentation, so I will get that launched right now. If folks can tell us, again, you can select as many of these as apply to you, but asking if you conduct some sort of validation to check the accuracy of the bicycle and or pedestrian counts that you collect. So yes, you validate your continuous counts. Yes, you validate short duration. No, you collect but not validating continuous or not validating short duration, or just you don't currently collect pedestrian bicycle counts. So maybe we'll spend just about 10 more seconds on this because we do have quite a few questions to get to, so I don't want to take up too much time, but please go ahead and cast your vote and we will share the results with you. And I think Frank and Sarah, you may not actually be able to see the results when I turn them around, so I'll try to dictate what they are so you can get an understanding of what people are saying as well. So maybe 3 more seconds on the poll question and then we'll close it up. Okay, I'm going to go ahead and close it and we will share the results. So right away, about half of those who voted don't currently have bicycle and pedestrian counts. So this has hopefully been really informative for you all to kind of think through all these issues maybe in advance before you start your count. The next highest option with 25%, no, we collect counts, but we don't validate short duration counts. And then yes, we validate short duration with 18%, and then almost tied at 12 and 14%, where yes, you validate continuous, or no, we collect but don't validate continuous. So kind of all over the place, but one clear option there is that a lot of folks on the webinar today don't currently conduct counts. So that's very interesting for us to know, hopefully interesting for you all as well. We are going to turn things right back to our slides so we can get into some of the Q&A. So if you just give me a moment to do that. We'll get our slides back up and running, and we'll have our little question and answer. Okay. So one of the first questions that came up, excuse me everybody, I'm running into some screen issues here. I'll go ahead and ask our first question while I'm fiddling around with the screen. One of the questions that came up that we got a lot of is, does this type of counter accidentally code or count segways, dogs, deer, carbon bikes? So instead of asking each one of those questions, I wonder if you all have thoughts about what we can do to think about those issues maybe more broadly. So is there a good source of information for what we might be over or under counting in terms of what we've got, you know, what we're selecting, what kind of counters we have, and what we might be over or under counting in terms of non-bicycles and non-pedestrians? So would anyone like to field that one? It seems to come up a lot. Frank or Sarah, maybe. I don't know if you have thoughts on that. Probably depends, right, on what counter and what. Yeah.
It does, and Frank, I'm sure you can speak to some of the other technologies that we're not using. But for North Carolina, like I mentioned, we're using the passive infrared and the inductive loops. The passive infrared is going to count anything that goes by, a warm thing that goes by. So that means if you know, like for example, we have some of them where we're trying to count pedestrians on the sidewalk. But if you have a decent number of bicyclists that bicycle on the sidewalk for some reason, they're going to get counted as pedestrians unless you put in an inductive loop or some other sensor technology that can specifically separate out the bicyclist from the pedestrians. Likewise, if an animal, like a deer or a horse or something like that, if you're on a shared use path, goes by, it can get counted as a pedestrian. So there are some disadvantages to some of these sensors. For the inductive loops, the particular technology that we're using is supposed to separate out motor vehicles from the bicycles. It's supposed to separate out even motorcycles from bicycles. Again, with our validation, we can see how well it's working to separate that out and whether there's any overcounting. But I'd say, for the most part, it seems to be working relatively well in just counting bicyclists, which is what we want it to count. It'll even count tandem bicycles, however, it only counts it as one bicycle. So again, if you're thinking about the way motor vehicle counts work, a car that goes by only counts one vehicle, even if there's 5 people in that car. So it's the same kind of principle with the bicycle counts.
Yeah, I'll add that it really depends on the particular technology that you're working with. Those ones that give you a grand total number of people passing by, such as the passive infrared that Sarah highlighted, but also active infrared, those are sensitive to collecting counts of everything going by, not necessarily just humans, which is what we're probably looking for. So animals can trigger them. I've heard cases of light rail vehicles in the background triggering counts. So those types of issues can be in part mitigated by being careful about your installation and trying to avoid those things in the background that might lead to counts. For kind of edge case things like skateboards or segways, which are in most cases a fairly low proportion of the traffic mix, I'd say it's probably not critically important to get those 1 or 2 people counted out separately for most planning purposes. So probably not something to be overly concerned about. However, if you're in a very heavily touristed district with a lot of Segway rentals, you might be more interested in looking at that. And then things that classify bicycles based on axle spacing, there a lot of the accuracy, so that's pneumatic tubes, piezoelectric strips, a lot of the accuracy there comes down primarily to the classification algorithm that you're applying. And I know Chris has done some research on that particular topic, as well as looking at for inductive loops, those cases that do and do not trigger counts when you would hope that they do. So maybe she can speak to some of that past research here.
Yeah, so I just wanted to say about like the segways. So a lot of the tubes or some of the loops, depending on the configuration, are looking for a pattern of wheels. So if they do not see, if they, Segway would have like one set of wheels to them, they wouldn't get the other wheel on the bicycle, so they say, oh, not a bicycle, if they're classifying correctly. And then about the infrared, the height, as Frank mentioned in his slides, it's important to follow the manufacturer's instructions, and usually they recommend a height that will exclude most dogs and coyotes and so forth, but hopefully include most children who are walking. So those are important issues.
Okay. Really interesting question that I got that I don't think we touched on it really, but it got me thinking about combining count data with sort of maybe other data people have access to. For folks who are particularly interested in looking at pedestrian and bicycle access to transit, are there thoughts on if you're putting counters near at heavy transit center locations, transit stops? On one hand, you think you may have an issue with maybe some overcounting if people are milling about and that sort of thing. But then the question goes on to ask, if you can get good counts at those types of locations, are there any good examples, or are you aware of any studies that have looked at count data along with maybe some boarding and alighting data to kind of look more broadly at access to transit and maybe using that in planning? Just looking around the panel to see if anybody has thoughts on those issues.
I know that Los Angeles Metro is it's soon going to be doing some, has started doing their own bike and pedestrian counts for this particular question of looking at the first and last mile, which they are considering to be part of their service. And so I think there is interest in some transit agencies to be looking at this type of data. I'm not sure how that will be paired with the boarding and alighting counts, but seems like there's probably some sort of relationship there.
Yeah. Okay. Any other thoughts, Sarah, on the transit station issue or transit location?
Not specifically. It's definitely something that we've considered, down the road, that it may be a way, another data point for short duration counts to help fill in the understanding of your network. But right now we haven't directly been using those data.
Okay. We had a lot of questions today and in Tuesday's webinar coming from folks who are either maybe just starting out with count programs and really haven't gotten off the ground yet, or are in more rural locations, not really in a dense urban environment. And so curious to know if you all have specific recommendations for how a community in that position, a group in that position might start out with developing some early counts to kind of get a sense of their locations. So asking questions like, should they start with some seasonal manual counts, maybe identify a few priority spots for pneumatic tubes and some permanent count locations, and with the understanding that in some rural locations the infrastructure is maybe a little bit more, it's maybe disconnected, a lot of it may be shoulder locations where they're not necessarily bike lanes or sidewalks, maybe a trail here and there. How would you, kind of as a big picture idea, go about maybe giving advice to a community like that?
So I'm going to jump in and say a few words from what I've learned. I think there are many approaches. Doing a manual program first is often a pretty low-cost, easy way to get your volunteers involved and get an idea of where might be a good location to do a more permanent counter. So I think that's a good step, especially for a rural area. I remember Boulder County, when I lived there, they did some rural counts with manual. They had people sitting out there in the ditch, counting for a day on a beautiful Saturday. So that can work. And then once you've figured out sites, you can put in some permanent count sites, or at least one. I always recommend getting one in as soon as possible because you can never recreate that pattern that you're seeing, which is particular to your weather and your conditions. But then combining, if you have a motor vehicle tube count program, some jurisdictions, some counties, rural counties, are combining that with their bicycle count. So you, as Frank was talking about, if you have the right classification scheme, you can use that technology to count both bicycles and motor vehicles and incorporate that into your motor vehicle counting program. Now, you have to be careful about this because you can do it wrong very easily. And we did a study in Oregon for Oregon DOT where we looked at a rural site, actually had high volume bicycle volumes, relatively low motor vehicle volumes, still more than the bicycle volumes. But we found that if the DOT used their standard procedure, even though the manufacturer of the tube said, oh yes, this should count bicycles, we were only counting a third of the bicycles. Whereas when we used a bicycle-specific classification scheme and were careful about the installation and followed best practice, and there's a bunch of papers that are out about how to do that, then it was pretty accurate, and we had with less than 20% error. So the moral of the story is just make sure you test it and it's working with your equipment, with your staff. But I know of 2 counties that are doing that, Boulder County and Hennepin County in Minnesota. So it can be done.
Frank and Sarah, any other sort of big picture recommendations for maybe a rural or small community kind of looking to get into the counting game?
Yeah, I would definitely kind of piggyback on what Krista said and echo some of that. Finding ways to integrate with what's already happening in your area on the motor vehicle side can certainly be a win-win. But, and short duration counts, definitely are kind of a lower cost way to start, but again, you know, it's going to be really difficult to be able to compare apples to apples if you can't extrapolate to get those annual average daily volumes. And so you really do need to consider at least having, you know, one permanent count station if you can within that rural community. We've been particularly struggling with this. North Carolina is still overall a rural state, and right now with our continuous count program, we've been you know, it's open to any agency within the regions that we're, you know, as we're rolling it out, but we're not seeing a lot of positive response from the rural agencies, and so we've been talking about some strategies for that. I think probably it's going to make a lot more sense for them to maybe utilize the continuous count data that's collected at some of the urban within urban agencies, even if they're on rural types of roads within those agencies, and to maybe highlight and push rural agency involvement as we roll out the short duration arm of the program.
Very good. I want to get to just one more question. I think we just have time for one more. We got a few questions about how different types of climates and temperatures can maybe influence which technologies a city or a community may decide to go with for their counts. So some questions about, for example, do infrared sensors fare well in colder and wetter climates? Or we had another one asking if thermal imaging and passive infrared are affected by really high temperatures during the day. So can you speak about maybe if a community is in a certain place and they always are hot and sunny, or if they're always kind of getting a lot of snow and ice and having a lot of dark days, are there certain directions you would send those cities in, or look to certain technologies over another?
Yeah, I haven't seen too much effect of temperature on accuracy during the NCHRP study for those infrared sensors. We did have a few hours that were approximately body heat temperature out, which is where we thought that the accuracy might break down, and didn't observe that occurring, so that was promising. I did see one paper come out a couple of years ago looking at passive infrared technologies in very cold settings, and they saw some decreased accuracy, which they attributed to the insulation that people were putting on themselves with their heavy coats, potentially affecting the accuracy of the sensor.
Okay, great. Any other thoughts on that?
In the study we did in Oregon, we seemed to, and I had a question for you about this, Frank. When you did that passive infrared, did you see anything with the FLIR? Sorry, I can't remember. Where you had high temperatures, did you test that? Because we found when we were testing that type of technology, the thermal camera, that we did have some problems in high temperatures around 96 degrees.
So in the NCDOT study, our thermal imaging testing was pretty limited. We just had one device installed in the follow-up round of the study, and so there was not as much variation in the weather as we might hope for a comprehensive evaluation, and I don't think there was really enough to get at that particular question there.
Yeah, so the jury's still out, but okay, there may be some problems.
Okay, all right. Well, we'll have to leave it there. Unfortunately, that is all the time that we have for discussion. I did put our panelists' contact information up on the screen, though, as well as our sort of general email account. If you didn't get your question answered and you would like to follow up with us, we encourage you to do that. I'd encourage you also to take a look at the webinar archive page when you get the link. There are a lot of the resources we discussed today, a lot of further reading that may help answer some of those questions. So I'd encourage you to go there. You will be receiving an email later today with a link to the archive page that I mentioned, as well as instructions for downloading your certificate of attendance. I wanted to let all of you know that a very brief survey is going to appear when you exit the webinar today. We'd very much appreciate your feedback and your comments on today's presentation, and maybe your thoughts on some other topics that you'd like to hear about in the future on our webinars. I'd like to say thank you again to Kristen Nordback, Frank Prue, and Sarah O'Brien for delivering today's presentations. And thanks very much to all of you for attending today's PBIC webinar. And I hope you all have a great day. Thank you.